My name is Marcos Colina. Today we are going to talk about the Erasmus Bridge, located in Rotterdam, South Holland, in Netherlands. Rotterdam is a city located in the south of Holland. It is a port city, one of the biggest of Europe and the world. It has about 2 million inhabitants in an area of 319 kilometers per area. As a port city, the need of bridges and the load and charge for ships system is really important. One of the most impacting bridges above the New Meuse River in the is the Erasmus Bridge. The Queen Beatrix opened the bridge on September 6, 1996, having a cost of 165 million Dutch guilders, about 75 million euro, to construct it. This is a cobble-style bridge. Uses a system of steel tensor that supports its weight. The Erasmus Bridge was designed by the architect Benjamin Berkhout and completed in 1996. The 802-meter long bridge has a 139-meter high asymmetrical pylon, earning the bridge its nickname of the Swan. Has a main span of 280 meters and a weight of 6,800 tonelads. The material used in the bridge is steel for the cables, the pylon, and the structure of the bridge, and of course asphalt to cover the bridge. The technology involved in the construction of this bridge is closely to steel management. This bridge uses steel cables joined to the pylon by bolts in one side, and in the other side have strongest steel tensors, only 2 of them, that equilibrate the tensile strength of the pylon and the other tensions, avoiding the torsion in the pylon and converting this to compressive strength that is transposed to the basement, also made in stainless steel. The cable-style bridge has the opportunity to experiment with long distances without the flood, and also gives an opportunity to explore all the plasticity of the material, the freedom and the structure. This kind of bridges offers also the curious game of rhythm with the download of the pylon behind a point into the city. The structure is supported by the Swan principle, but the kind of effort that the people who work hard is impressive. The impressive view of this bridge are the attractive of the simplicity of the structure conceived in stainless steel. The southern span of the bridge has an 89-meter long bicycle bridge for ships that cannot pass under the bridge. The bicycle bridge is the largest and heaviest in West Europe and has the largest panel of its type in the world. This bicycle allows also the traffic of very big ships because it rises completely, leaving free the height of the ships to pass through, but taking care of the maximum width, less than 89 meters. Constructed to facilitate the orchestration of traffic load, the bridge design is inspired by and in turn reflects the industrial character of Rotterdam, adding to the narrative of the city. The bridge operates as the last crossing point between the northern and southern areas of the city, with its structural scale and design articulation has become an aesthetic landmark within the surrounding skyline. The 139-meter tall pylon will become a new point of orientation connected with in and out in the new development in the Couvain-Zuid area. The asymmetrical form, with its rocket construction in sky-colored steel and its long cables, conveys the mobile force, that is to say, the multitude of the public, urban, constructive and architectural considerations that have been at the basis of the bridge. All details of the bridge have been treated integrally, from the 5 different shaped concrete piers of the railing, the landing, the joints of concrete and concrete, steel and steel, concrete and steel. The finish of each part is of crucial importance to the materialization of the wall. Shortly after the bridge opened to traffic in October 1996, It was discovered the bridge would swing under particularly strong wind conditions to reduce the trembling, stronger shock tempo when studied. A lighting plan was made to emphasize the multiple identity of the bridge as an urban artifact. At night, when the appearance of the bridge is reduced to a solid, special lighting from the inside will show up the interior of the bridge, with its boundary cover rising steeply above the water as a dematerialized image of its daytime self. The asymmetrical pylon, with its bracken construction in sky-colored steel, has 2,000 different faces. The long, diagonal cave is physical and metamorphic like Rotterdam south of the city center. 32 stays attach off the tube of the pylon, and a back stay keeps the structure in balance. 5 concrete bridges carry the steel decks, which is divided into 2 footpaths, 2 cycle paths, a tram track, and 2 carrying way for motor vehicles. This bridge is a way of communication between the numerous semi-islands that conforms Rotterdam. By this purpose, the bridge was conceived and created to the opportunity of giving not only communication and connection. Also, this bridge becomes itself in a reference point inside Rotterdam and outside it. Also, it is a structure become art. This is because the bridge in all the nights and days of the year has different artistic and illumination interventions that give it in our character. This bridge can be seen by all the places around Rotterdam and even far away. In an aerial photo of the city, this bridge is one of the attractive of Rotterdam. This bridge is one of the best projects designed by this architect, Ben Mamberko, and it is a masterpiece of architectural design and structural engineering. The Erasmus Bridge is such a dramatically built-in bridge building that it has even become part of the city's official logo. The structure was in a really fascination, permits people to move quickly from one end of the city to the other world, offering beautiful views of the city from a variety of angles. In short, Erasmus Bridge is a public space in its own right, suspended in the air and yet preserving physical and metamorphic continuity with the city surrounding it.